Okay, good evening everyone. I guess... Yes, we can get started. Now we can get started. Okay, so I think I can hear myself on YouTube, which means you should be able to hear me as well. Good evening everyone, and today we are going to do the third part of my, code review, let's call it, series, which basically in the first two parts we both reviewed and fuzzed my old web server and also did a black box security review of it, and we found actually quite a lot of bugs, and some of them pretty bad ones. If you didn't watch the previous parts, I don't think you need any information from there for today's stream, since I'm going to be kinda talking about the fuzzing which we did back then, but I will also but that's not really, you don't really need that, you just need to know that what fuzzing is. Yeah, basically. And the idea for today is basically to talk about how to improve fuzzing. If you have a fuzzer set up and it's running and it's finding bugs or not finding bugs, how do you know that it actually is doing its job? Or actually, how do you know that you have good coverage? How to improve it, and how can you measure it? Because like a lot of folks, when they are, especially like beginners, right? They set up a fuzzer and let it run for a week or two, then shut it down. If they have any bugs, then they report it. Now that's not really the full story here. The full story is that you should always iterate on your fuzzing setup, and be sure that it actually reaches all the places you want it to reach. And if it doesn't, then maybe you have to tweak the harness, maybe you have to create some samples for the corpus by hand, maybe you have to write another harness to reach other areas of code. So that's what we are going to talk about today. Now, today's moderator is Foxtrot Charlie, and you can see his nickname right here. So if you have any questions during the live stream, then you have to write to Foxtrot on YouTube, or you have to write to Foxtrot on Discord or on IRC. Well, if you're on our IRC chat, then you can use !Q and then ask the question, and I will not see it because I forgot to turn on my the portal with the questions. Okay, here we are. Perfect. Now, okay, let's move here. So, let's see if my keyboard actually works today. This is Foxtrot's website, and I guess we can always, as always, check if he has any new posts for us, and he doesn't. Yeah, but do visit, it's foxtrotlabs.cc. Now, some random announcements and other stuff, totally random. Actually in Poland, there's one of the biggest, I think it's the biggest conference in Poland, security conference in Poland. It's called Confidence, and it's like running for 15 years or so. And I did tell you about it on previous live streams as well. Anyway, the conference is over. It finished yesterday evening, and the P4 team, which is, one of the best CTF teams in the world, organized the CTF there, and Dragon Sector actually won. So congratulations to my team members who were present on site and who won it, and also congrats to Hacksorp Shore CTF team for the second place, and Mate and Mim for the third place. Well done and well played. I guess you can see also the full scoreboard here. No solves yet. Okay, we cannot see the scoreboard for some reason. Oh well. Then, as always, we are still looking for articles for Paged Out, which is, again, my new project. Well, my and several other people's. For example, Foxtrot Charlie is also helping us, and also KrzaQ, Yuru, and Kele, and some other people. Basically, it's going to be a free magazine, distributed in electronic form, about programming, hacking, security, retro computers, modern computers, electronics, demo scene, and so on and so forth. And we already have 28 articles submitted. I'm waiting for 50 articles to basically say, okay, now we can finalize the first issue and ship it. Which will probably take some time, because it is a pretty experimental magazine, and we have pretty unorthodox approach to how we actually do desktop publishing, so this will be funny, and there will probably be a release candidate or a beta version published before a final version is out. And yeah, so we are still missing around 20 articles. If you have something you want to write which fits on exactly one page, then do check out the Paged Out Institute website. Cool, then yeah, this one was funny. Like, I think yesterday on Twitter and IRC and everywhere, basically folks started to point out that, hey, actually there is a funny vulnerability in Vim and NeoVim using mode lines. So mode lines are basically in like a source file or a text file in a source file, in a comment, you can put some settings for Vim, like what do you want the tab width to be, what kind of indentation you want to use, what kind of language is this, so that Vim can, you know, properly color the syntax. And it turned out that you can actually escape from the limited set of commands into code execution, and this is what happened. So update your Vim. This is a pretty funny vector of vulnerabilities, so yeah, that's pretty cool. I guess I should give you a link to this. Here we go. And then, oh, yes, this. Yeah, this is totally not related to security. I just finished reading David Weber's series about Honor Harrington, and it's military science fiction. If you enjoy it, I really recommend it. I finished reading 14 books, like each book is like 700 pages or so, a few days ago, and now I'm going through short novels from this universe, and it's just amazing. I fully recommend it. If you're into military science fiction, check it out. On Basilisk Station is the first volume. And I guess this brings us to our main topic, but before we go, but as usual, I will try to answer a couple of questions that already appeared, and we will start the actual topic in 5 minutes. So, let's see. You should see the questions showing up here. Again, if you have a question anytime during today's live stream, be sure to write to Foxtrot Charlie, because I'm not, well, I am looking at chats, okay. I do have 3 chats displayed on my one of my LCDs, but if I'm focusing on the code, I will miss the question. So be sure to ping Foxtrot Charlie, because he will just put the question on the list, and I will go through the list later on. Now, one funny thing, if actually at some point my stream freezes or it's cut off, that's because I have some problem with my water cooling and I didn't fix it yet. So I might have to switch to lower power setting for like 10 seconds, because usually the pump after 10 seconds starts working again. There's an error bubble probably somewhere there. Anyway, and worst case scenario, my CPU temperature goes to 100 degrees and my CPU will turn itself off, not to harm the hardware. And I will be back after a restart in that case. Przemek says, is it worth to update drivers regularly on a computer, or is it better to keep it as is, basically, and why? It's a good question. Basically, it's like this. From a security perspective, if a driver exposes some kind of API which any user can use, then it's good to have it updated, because there might have been security fixes there. And like graphic colored drivers might be one example, right? Because every non-privileged user can access the graphics API. On the other hand, if like it works, then you don't have to, and it doesn't expose your computer to any additional problems. Like usually on one user machines is not really a problem, right? Because you have like your main user and you're running everything from one user. So if somebody executes code with the privileges of that user, they don't really need to attack a driver to get execution in the kernel and so on. On like some more complicated setups, it might be more important. Now, that being said, if a driver doesn't expose any attack surface, there are no devices in the operating system which somebody can access and chat with the driver, then it's not really super important to update it. it might be worth reviewing the changelog of the driver if a new driver comes up and looking like, hey, is there anything super important there that I need to actually really update the driver? One example would be if you have, for example, in the changelog you spot something like, this fixes a bug with cooling of the GPU, where in some cases the cooler would stop, like the fan would stop, and the graphic cards would fry itself, then you probably want to update the driver. On the other hand, if there are like cosmetic fixes, then you might just not care. I don't think there should be any downsides in modern world about updating drivers. There were problems in the past, but sometimes a faulty driver was happening, but showed up from time to time. But I didn't encounter any problem with drivers for years now, so I wouldn't be too worried about that. What do you think about new vulnerabilities in Intel CPUs? I still didn't look at them. Apologies, so I still don't have any good opinion on them. What to do if you are stuck on a CTF challenge? Really good question. There are a couple of things I normally do. First of all, I try to restart the challenge. As in, I usually have a challenge directory. Like every challenge has a separate directory, right? So I create a new directory for this challenge and I start from scratch. I ignore everything I've done so far, all the scripts and so on, and I start from scratch. And with the analysis, recon phases and so on and so forth. And maybe I actually venture to some avenue where I have not been before, and that allows me to solve the challenge. If that doesn't work, and if I'm tired, if it's like 4 a.m. or something and I just don't see what I can do to solve this, then I just go to sleep. Because when you're rested, at least when I'm rested, my mind operates better. And it's actually like there were a lot of cases where I just went to sleep, I woke up in the morning after 4 hours or something, went back to the computer and I was like, okay, this is the way you solve it. And yeah, really multiple times. So getting arrested is a good idea. Another thing is that your mind might probably still work on the problem and munch on the problem, so you don't lose too much. Going on the walk is also a good idea. Then when that fails, and standard debugging methods like explaining the task to a rubber duck or whatever also don't work, then I usually do it in a way that I write down everything I know about the challenge in a shared document with my team. So in a way that if I would pass this task to somebody else in the team, this is the set of notes, everything I know about the task, so somebody with a clear mind with the whole picture can look at it, because I might already be looking too deep into the problem and not seeing the whole picture, right? So yeah, so I write that down, and in some cases while writing it down, I decided, hey, I'm actually writing about something, but I didn't fully check this, maybe I should recheck it, and it turned out that, hey, that's actually the proper avenue to go, proper path to go to solve the challenge. Now, the last thing to do is basically, the last thing I do is to tell my team, hey, I have no idea, does anyone want to take a look, anyone want to join? And usually there is 1 or 2 people who are show me what you got, and I give them the notes which I've written down. And in some cases they have no idea, in some cases they have an idea and it's pretty obvious to them what you have to do, and I didn't just figure it out because I either was missing some piece of knowledge or I just didn't think to check something. And in cases where, in the cases of tasks which are left until almost the end of a CTF, then usually, since we have a lot of tasks solved, most of the team is starting to look at this one specific or another task together and brainstorming ideas on our chat to try to approach it in one way or the other. And yeah, that also works. In multiple cases, that also worked well. What are the programming languages that you learned? Oh my, this is a long list. I am programming for a lot of long time, really long time, and a lot of time. So it's a long list. The ones I'm currently using the most would be Python, C++, JavaScript, assembly, and sometimes PHP. though like, yeah, through like both my hobby programming and my career, there were a lot of languages, including quite a lot of Perl, quite a lot of Java, both for mobile and not for mobile. Well, more for mobile actually. A lot of different basics, like Atari Basic, Commodore Basic, GW Basic, then Q Basic, Visual Basic, and like C, of course. Some scripting languages, Bash, Batch. I've written really complicated scripts in both of them. MIRC script. I've also written quite a lot of scripts in that. Then some like specific languages for various scripting and of various stuff. Like there are something called like eScript. And I'm pretty sure I am missing a couple of languages still. Not to mention like a lot of different assemblers. So yeah, but I'm currently focusing mostly on the ones I've mentioned before. Did you play Facebook CTF? And what about its winners? Yes, this is a good story. I didn't. I might know people who did play. So the story is like this, that Facebook CTF happened during this weekend, and not this. No, during this weekend, yeah. And it was won by a team who was initially called G+, and later the name was renamed to Visit and a link to Google CTF. So yeah, that's like trolling level master. And it was like there were a lot of great teams playing. So winning that and pulling it off does require a lot of skill. So I totally like in awe about what these folks did. And the last question, and we'll get to today's topic. What do you think about the amount of bloatware added to laptops with pre-installed Windows? Yeah, I do not like bloatware, and I usually like reinstall like the system from scratch, format the hard drive and reinstall it from scratch because I care little for bloatware. And there were problems in the past with security of that bloatware as well, so yeah. I mean, I understand why they do it, right? They probably want to add some value to their brand of hardware, but if you're a power user and you have your own system configuration that you like, then you will care little for the bloatware and it will be just annoying for you. But it might be useful for less, less advanced users, right? Like, there are not a lot of power users. Most users do not think like power users, so they care about different things. They are not wrong, right? They just have different priorities, so. And they might enjoy some of the applications which are embedded, like with the Windows installed, for example, Windows installed on a given laptop. Is Google CTF gonna have some more sandboxes this year? I cannot comment on that. The CTF starts in what? 2.5 weeks, I guess. So yeah, you will see when the changes are announced or actually released. Yeah, sorry. What are all the books behind you? Okay, so that pile there, which you see, would be like on my yes, this pile of books. That would be what my wife says is her birthday gift. That would be a lot of fantasy books. And if you look there, then up like the outermost shelf, so this shelf here and the topmost row, these are my technical books, and everything else is basically either it's a mix. It's like fantasy, science fiction, like physics, mathematics, art, like totally a mix. And I'm pretty sure even some manga is there. Even while we do have another bookshelf for manga. So yeah, we might go through my library of technical books in someday if you would like. Just let me know. We did that on a published live stream like 2 years ago or something, and but I have some interesting books, I would say. Cool. So You and your wife like to read. Yes, we do, and I read like above average of books what people read, and my wife, like, she reads like way more than me. So yeah. Anyway, books are fun. I always liked reading books. Cool. So fuzzing. Yeah, let's do fuzzing. Perfect. This is our target, and what we did last time, this is again like a web server, and the web server has its own scripting language, which we actually like got to the source code of the scripting language using several different methods. So let's do it again. Yeah, this is how the scripting language looks, and this is one of the vulnerabilities we found, by the way. And what we did last time is we basically wrote we pulled out the fuzzer, which does we pulled out the parser, which does parsing of this XML-like looking script, and we fuzzed that. And we found a couple of vulnerabilities, nothing major, a lot of off-by-ones. And the funny thing was that there was usually like a comment, hey, there are no buffer overflows here or something, because we checked against it, and then off-by-one right there, like next line. So that was hilarious. Yeah. Yes, I did code this, but that was, what, 15 years ago. So I was young and stupid. And now I'm old and stupid, but whatever. You live, you learn. Now, oh wait, I actually do have this opened already. Yes. This is the fuzzer which we wrote, and it's not too long. We basically like pulled out all the libraries we needed. We did some initialization, which was basically like copying some stuff from copying some code basically from the server source code. And then there are some procedures which don't do anything, and yes, this is the main function. We used libfuzzer, and libfuzzer has this convention that you have one function, and this function is being called by the fuzzer. The fuzzer runs in process, which means it's actually like what we have here, a main function is added where the main function is actually doing the fuzzing by calling this with the data which was mutated unknown to us in an unknown to us way. And yeah. And we, what did we do? We basically passed it to the parser, and that's all we did. And we did get a couple of errors. I actually left it running after the live stream, and after the like several hours it crashed due to like it didn't crash any time after the stream. So that means no more crashes, no more bugs were found after the stream. The one time it crashed after several hours, it was out of memory. And we knew about that because we did turn off deliberately the leak sanitizer, which is part of address sanitizer packet, basically of the sanitizers. Yeah, and we decided to turn it off. Now, what do we do today? Now, the basic step, if you want to be sure that your fuzzer is running correctly, is you need to know coverage, like how much code are you covering. And it's actually pretty easy and pretty complicated. The reason you want to know that, because for example, there might be somewhere in the source code, there might be some complicated check. Like you look as a human at that check and you're like, oh, like this need to be set to this and this need to be set to that. And you're quite easily can set everything correctly. Now the fuzzer, for example, the fuzzer cannot randomly, even a genetic fuzzer cannot randomly create a file, or it's improbable that it would create a file which contains all the proper things so that that check would pass. So if we do not analyze what the coverage is, we will not find such places. If we would be running like Angular, for example, or some other tool which it also works, like tries to solve all the constraints to reach all the blocks, and that's actually works with a fuzzer, then it might be able to get into some blocks, but then again there might be some really specific like cryptographic blocks where the fuzzer would not venture on its own without a human helping it to actually reach there. That's one thing. The other thing is that, hey, we are using this like source parsers parse function, and Maybe there is like another function which does parsing and enables some different features. We don't know. Right now we don't know, we might have missed it, but if we would analyze the coverage, we would know where to which parts of the file the execution actually reached. We might be able to just randomly stumble on some features which are not enabled due to a check and not covered, and then we might backtrack from that and find another function which like is running with some other features enabled. So that's why it's super important to know what is the coverage of your fuzzer, and to help the fuzzer with like to iterate on the fuzzer basically to get the best coverage possible. Now, getting like 100% coverage isn't always feasible, and it's not always important. For example, if there are places which are unreachable because like of some environment variables which are not set by the attacker, they are set by like the administrator who is actually like starting it, and they are related to like should the message be displayed in like this language or that language, then you might just not care about it. On the other hand, there might be a vulnerability there, but maybe there isn't. And there might be blocks which are basically like parsing the arguments of the file, right? And you might want to cover everything else, but you might not care about that argument parsing blocks, because there might be like not interesting, and also that's not an attack vector for you. An attack vector for you is something which you can reach as an attacker, which you can influence as an attacker, and probably like arguments passed to the application are not on that list. So, there's a question. Is there any way to stop cryptojacking malware? You mean like ransomware? Is that what cryptojacking malware is? What's cryptojacking? Cryptojacking. Oh, you mean like Bitcoin and other stuff? I don't know. Good question. Don't have malware. So I guess the answer to this would be, if you have something super sensitive like Bitcoin, just buy a cheap laptop and do everything Bitcoin related there and nothing else. And everything else you do on your main computer. And that way there is a separation, like an air gap, but you shouldn't have to worry about malware in that case. Yeah, that's like, I guess, security in the end boils to that. Like, no matter how hard you try to like, harden your system, in the end probably the best solution is just to have a different machine for sensitive stuff. Because the air gap is a pretty strong boundary. It's not an ideal boundary. There are ways to jump from one machine to another over an air gap in some really specific cases by using a human or maybe like some other components of the system, but yeah, still is way harder than exploiting a kernel. Cool. So what we need to do basically is we need to let's compile this, and then let's dump the coverage. And while the coverage will be in the form of probably basic blocks, which means addresses. We will get a lot of addresses, and then we'll have to convert these addresses to, for example, like functions and line numbers, or files and line numbers. So debugging symbols will be needed. And then when we have that, we can create a short script which will just output the source code and note which parts of the source code were actually reached and which were not. And yeah, it's quite easy to write this. Some tool sets available out there already have this functionality, but you actually just give it a corpus, give it a target, give it the directory where the source code is, and it will like get you a copy of the source code annotated with which parts are being reached and which are not. But again, it's easy to write, so we will write it. And okay, I do need a Linux console to do this. Okay, here we go. Wait, where am I? Yeah. Okay, perfect. So we have a fuzzer mk file which looks like this, and this is compiling our fuzzer, which I guess we already chatted about this last time. how this is constructed. The important thing here is the fsanitizer, which adds the fuzzer and adds the addresses. And I'm actually pretty sure that the fuzzer also includes the sanitizer family coverage information dumping. So that's good. So let's do make fuzzer mk. And the GGDB here is to include GDB symbols as well. This allows us to use, for example, address to line tool, which does conversion from an address into an actual file name and file line. Okay, now let's do export. Sorry, export, and we do. What do we do? We do asan options verbo ct equals 1 to see what's going to happen, and we are going to run the fuzzer. What's the name of the fuzzer, by the way? Say out? Yeah, say out. I didn't specify a name. Okay. And let's run it with a single file, and the single file is going to be what's this? Oh, for example, this file. Crash, blah blah blah, something. It was a crash, it shouldn't crash anymore, but whatever. Let's just run it with it. So crash, F7, yeah. And, this is the leak sanitizer. This is about leaks, and we do not care about leaks, so we can turn off this with detect leaks equals 0. I guess we can pass it as an argument, or we can also, I think, set it in asan options. So let's set it in asan options. Yeah, it also. And it says it's running, it's executed, and that's it. Now what we want to do is we want to actually dump the coverage, and to do that, I think it was coverage equals 1. And okay, that wasn't what I wanted to do. It might not be it. In case it's not it, we will have to compile it with another set of options, but just let me make sure I am not making any mistakes with the name of the option to dump it. Yeah, so this is the sanitizer coverage, and we are not including this option because I think it's implicit in the fuzzer. But what I want to do is coverage equals 1. Yeah, asan options coverage equals 1, as I did say before, and it creates a sankov file. So are there any sankov files here? There are no sankov files. So what I'm going to do is I'm not going to touch this file. I'm going to create a copy of it. So let's do like coverage, and let's work on this. Here we go. This is a copy, and I'm going to make a copy of this to like Gosu cove. Okay, now I'm not using a fuzzer, and I'm not using any sanitizers actually. I just want the coverage information. Because again, this isn't to find vulnerabilities, this is to just get the information which parts of the code have been reached. By the way, you do not have to compile it in. Sometimes you can use like tools like perf. You might want to go back a couple of live streams where we did solve an CTF challenge based on perf coverage dumping, but since this is a virtual machine and I cannot really use perf because it uses CPU features, then yeah, I have to compile coverage information dumping here. And there are multiple ways, again, to do it. Like, even without compiling it in, you can create a GDB script to dump it. So there are multiple ways to do it. Today, I'm just going to compile it this way, since that might be the easiest way, given that we are already using the LLVM clang or clang. Now it's compiling a little, which is good. So I'm going to find what's the name of our fuzzer, by the way? It's parser fuzz. So let me open parser fuzz in that case. And we have to add we have it open. We have to add a main function because there is since we didn't compile with the option fuzzer, we do have to create our own main file. And I will do it like this. I will define add main, or like my main, cov main, maybe cov main. If this variable is defined, and here in the cov.mk I will actually define it, so let's do cov main, dcov main. Yeah, equals to 1. I don't have to add this equals to 1. Let's just add it like this. And let's do the main file. No, I actually don't need the argument, so it will be... Okay. Now, if the argument count is equal to 0, equal to 1, then we just like print standard usage cov, what was it called again? Gosu cov 1 file 2. Sorry, let's do it properly. Okay, file 2. Okay, good, and then return 1. Do we have standard? Yeah, we have stdio included. Return 0. Otherwise, we have to read the file into the memory and then pass it to this function. I do not remember if we. Let's assume we actually add a trailing 0, a null byte at the end as well. I'm pretty sure we dealt with all the problems related to that last time, so I'm just going to do that. Okay, so how do we do that? We have this buffer and we need to first open, so actually for int I equals 1, for each argument, what we want to do is we can do it slow way or fast way. Let's do it slow way because of reasons. We want to open the file. Oh, this is C, not C++. Okay, never mind. We want to open the file, which is argv of I, called argv of I, and we want to read binary data from it. If the file is like null, then we want to complain about it. But we are not going to bail out because it's not really important. So here we have it open, we have the file open, so let's close it and let's check what is the size of this file, allocate the buffer, read the data into the file, into the buffer from the file, and then call our function. So to check the file size, you do it like this. We probably know. You go to the end of a file with a reading caret or reading head, whatever you want to call it, or however you want to think about it, a reading pointer, I don't know. Then you get to this, you do ftl, you basically check your location when you are on the end of a file, and your location is basically identical to the size of a file. One warning here, if you are not using B under Windows and you are reading text files, your mileage might vary. You might get really weird results, so don't do this for text files on Windows. That's because, you know, the end of line is being converted and you will get a difference. It should be fine while reading, but the file size would be just incorrect. Okay, so this is, we get the file size, now we allocate it, so that would be malloc and a z. If it didn't work, we can complain, so if buff, oh, let's do it the other way. If buff is not null, otherwise, let's do error. Not enough pylons, like, whatever, that doesn't matter, it's just an error. And we do not continue because we want fclose to be called, so that's cool. It's like pass through. Here, what we want to do is we want to read to the buffer this amount of bytes from the file. And once we have read it, we actually want to call this function, right? And it takes, what kind of buffer we have? Okay. Perfect, that's better. and date. Okay. I actually am playing with the idea of doing like something like this. Here +1. This shouldn't backfire on 64-bit, but yeah. And then before reading, I'm actually going to do, or actually after reading, but that doesn't matter. Equals a null byte, just in case I'm going to add that null byte there, because I don't remember if in the source code of Gosu the null byte is actually added or not. I don't remember. Now, after it's read, we are going to call this function, and it doesn't matter what it returns, and we pass it both and size. Are we going to pass size +1? Let's pass size +1, or maybe let's pass size. Yeah. And here we can just free the buffer. So, yeah, that's basically it. We are just running without any mutating whatever we have read. And this way, we should be good. So, it says undefined reference to main because why? No, really why? Am I compiling the correct file? Yeah, parser fuzz. This is main. Are you sure you are actually? Why are you not reaching this part? Maybe I do have to put like this equals 1. Am I in the right directory? No, I am in the right directory, but what's... If defined cov main, this should be fine. Come on. Yeah, it is fine then. Why doesn't it see main? What kind of... This is cov main and this is cov main. Make. Oh wow. Yes, I expected something stupid like that. Thank you, Camille, for spotting it. Yeah. Okay, there are thankfully absolutely no errors and no mistakes, and the code compiled beautifully, which is not what happened. Implicit declaration. It's in stdlib and Linux. Okay, that's cool. So now, if we do Gosu conf and let's run it on one of the crashes again, nothing happened. Why did nothing happen? Because I probably need to add here okay. Okay, and now is written 60 PCs, 60 code locations to the file. And here's the interesting thing. What exactly is written to that file? Is it the address of every instruction which is executed? Is it the address of every block which gets executed? Is it something else? It really depends on this option. I'm not really sure what trace PC guard is in this case, and we will have to take a look, because it might be several different things. It might be either the beginning of every block, or it might be something else. Let's go for block and see what happens. Burn is no block. What are the other options here? Inline 8-bit counters. We don't care about counters. PC table. PCs. On every edge. Okay, perfect. If we have trace PC, then it inserts it's on every edge. And we have PC guard, which, what does it mean? What's guard? Oh, we have BB for block instrumentation. Can we use edge? Edge would be great. Edge is deprecated, but okay, that's fine. It compiled. Edge basically means that in some cases there are more ways than one to reach into a certain basic block. So okay, let's maybe do it like this. If you have like a basic block here, right, like a piece of code, and you have like another piece of code here and another piece of code here, and let's say we have another piece of code here. So you might be, if you have block coverage, then it's noted that this block has been reached, regardless if it has been reached from this block or from this block. It doesn't matter which block was executed and caused reaching it here. However, if it's edge, then actually, in case of edge, it does matter. And in case of edge, what's noted is, like for each edge, you would get, like for this edge, you would get noted this edge. And for this edge, you would get noted this edge separately. Now, the way it's actually made is quite funny, because what ASAN does, it creates another block, which is not really in the code, but it's a fake block, basically. And one of the edges is redirected to this block, and this X here is actually like the X of this block, and then that block goes here. It doesn't matter how it's implemented, it's important that it works. So I guess we don't care about edge either, we really care about basic blocks for now. So let's do it again, and let's try to dump it again for just one file. And okay, how does the dump file look like? It's not really long. I'm going to open it in hex editor because it is a binary file. Now at the beginning, let's maybe do it like this. Yeah, at the beginning you have some, like 64 basically tells you the bitness. I have no idea what the other stuff is. Some flags maybe, we do not care. What we care about is this, and these are just the addresses which have been reached. So each address is 8 bytes. No magic here. If we grab one of these addresses, let's grab this one. And again, this is little endian, so you do have to translate it to, can we actually show hexadecimal here? We want little endian, but we cannot show hexadecimal here, it doesn't matter. But yeah, we can still use address to line with, how did you use it? -E, I think, was for executable, and the executable has to be this Gosu cov, which we just created. Yeah, and then if we give it the address, which is 526CB6, it should tell us that, hey, this was the parcel line 20, and yeah, which means it's this, which I do not fully understand why this was reached, but it says it was reached. Okay, well, I believe you. Oh, it was reached because it's being called actually here, right? So that's fine. Then we can check the next one. This is not how you check it. This is, I'm just showing this to you so you can understand what we'll be doing with the script in a second. Let's get the next address. It's 6D C1, and it's line 31, so this line has been reached as well. But I would actually like to get some out of this file. Oh, for example, this address means that this line has been reached. So now what we have to do is we have to write a script which will open this binary file, extract all the addresses, and then run this address to line with each of the addresses and create well, basically a set of files which set of source files which are actually have annotated which parts of the source code was reached. So I will create a new directory for the sake of that. Let's call it cov output, but I will still create the script here. The script is going to be in Python because why not? So show coverage py, that's how I'm going to call it. And yeah, let's import sys, let's import subprocess because we will have to use that address to line. And let's do if len sys argv isn't 2, then sys exit usage show cov py and asdf file sumcov. Okay. Now here let's do a shebang user bin python. Okay, again, if you have any questions at any time, do write to Foxtrot Charlie. And I see there are a couple of questions. I will only answer the ones related to the topic now, and I will answer all the rest at the end of the stream. So Source code deleted rise, probably a bad question, but is there any reason why you use CLang over GCC? Yes, because the address sanitizer, the coverage functionality and the fuzzing functionality are both in GCC and CLang, but in CLang they are like the cutting edge version. The newest version is always there because the folks from LLVM are actually the ones who are writing these sanitizers, the address sanitizer coverage. And the fuzzers, like libfuzzer. So that's why I'm using CLang, because it just works better. Otherwise I would use like GCC probably. What was the reason of recent outage? Yeah, I cannot comment on that. So and I don't know either. So yeah, let's not go over. Sorry. So if we are already here, we have to now with open and the file name, which is sysargv1, and we want to read it binary as f. We want to, let's just get it to like a byte array or whatever. D equals, oh, let's just get it, we don't care about byte array. What we need and do care about, however, is struct. Yeah, so, sorry, no. If we read it, we can actually skip the first 8 bytes because we do not care about it. It doesn't, this is slow, it doesn't matter, it's slow. For I, we can close the file, and now for I in len of D by A, and this is actually an X range. What we want, that's not the way I want to do it. I want to do it like from 0 to length stepping 8. Yeah, this is better. Now the address is actually struct unpack q, which is q is for 8 bytes, is for a quadruple word, where word is supposed to be 16 bits. So yeah, 4 times 16 is 64, so 8 bytes. And now I need to give it the data, which is 8 plus 8. Sorry, I and I plus 8, and it returns a tuple, so I need to get the first element of a tuple, and yeah, that's our address. And now we need to run this address through address to line. Now there are actually a couple of ways to use this. We can either use it from command line, which is this way, or we can use it the way we used here. So we just pass all the addresses and then we read all the outputs, and this is a better way to do it. So that's how we will do it. Therefore, I will create this list of addresses, and I will push append the address into the addresses. Yeah. Now, having this, what I can do, I'm going to actually move it a little so you folks can see as well. I'm going to do. I need a string which I can pass it to. So addresses as string. I basically want to do a join on, and I probably want hex addresses, so let's do hex. Can I actually do like OX here? Yeah, I can do OX here, that's perfect. So hex of X for X in addresses. Okay. That's address, not addresses, but whatever, that's fine. Okay, now I get a string, so let's see how well that worked. And as you can see, it is Python 2. It doesn't matter. Like almost all the code is identical anyway. Python, where is my file? Is it not here? Where am I? Where did I create this file? Oh, I know. Wrong Gosu directory. Let me just copy it. Here we go. Apologies for that. Python showconf, and we need the sunconf file. Okay, yeah, so it read the addresses. The addresses are looking sane, therefore we can continue, which means we have to do sub process output check or check output. I think it's check output. And now we need to pass it the well, first we need to pass it the name of a tool, which is address to line, I don't remember which package it's from, but it's like bin utils or something like that, or like GCC or something. It's a pretty standard tool. You won't have problems finding it. Now what you do is you have to specify the executable, and in our case I will just specify it. It's what was it called again? Gosu. Yeah, Gosu. Okay, and now we don't specify anything else because we need to. You know what? I have to do a p out here. P open. Okay, and we need to. Do I need to do anything else here? I think I need to redirect the stdin to process pipe and std out to process pipe. Yeah, that way I can access the output while still providing the input, which is the important part. And now there is a function which is called, or a method rather, communicate, where I just pass the standard input here, and it will return standard. It will return two things: standard output and standard output of errors. And then if I print out standard output, I should have this translated to actual lines. So yeah, it works. It didn't work for all cases. In some cases, it seems to have no idea, which is quite funny. But these might be actually the edges, like the additional blocks added, which are not associated with any actual block or any actual line of code, and that's fine. We don't care about it at this point, so that's fine. So now what we want to do is we basically want to split the standard output by we want to do split lines on it, so we get each line, and for each line in this we want to basically check if the line is let's do this ln strip. We don't need to really do a strip here, but I'm paranoid like that. I like to do strips because it makes sure there are no, like, you know, redundant spaces at the end by accident. And now we do a split. So it's path and it's we will need OS, by the way. It's path and it's line, like line line number, and we do a split by this, and we hope there are no colons in the file name. If there would be colons in the file name, this would fail quite badly, but yeah, like we would worry about that in that case, but we will not have to worry about this, so I am not going to write any additional code here. And now what we also want to do is yeah, we basically want to store it somewhere. So file, as the files, and files is going to be a dictionary of files. If path is in the files, in that case files from path, let's assume that we have, what do we have? A setver. So let's assume we have a setver, so we do add and the line number. The line number is not an integer. Let's make sure it is an integer actually. Okay. In our case the path is not there, so we do have to actually initialize it, and to initialize it we can do a set with the same thing. Yeah, in Python, like, this is actually a set and this is a dictionary because this one doesn't have a colon. Yeah, and if it would have a colon, then it would be a dictionary, otherwise it's a set. A set is a, you know, like it's a dictionary without values. It's used when you want to check if something exists in really fast. You don't care like what value is associated with it, you just want to check if it exists. And we will want to go through each file, through each line, and check if that line exists in our set. If it exists, then we want to somehow annotate it. If not, we will not annotate that line. And now for each file, in files, actually, like, let's do it, file name and v, or whatever, in items, we open this file, so with open this file, read binary as f, and we will want to read all the files, so let's call it src, like source code, and let's read it, and let's split lines. Okay, and now what we want to do is for each line in this file, we also want to open the output file, which would be, what's the output file name? Output file name would be the OS path base name of the source, the file name. And then to this we actually add a new path, so we can do like OS path join. We can do OS path of join, or we can just use a string concatenation. And as I said, I created a directory for this, which was called conv output. So let's do this, and let's append it with a base name. If we would have multiple directories with source codes and there might be, you know, duplicate file names, this would fail hard, but we don't, so I do not care about it. We can actually take a look. Yeah, everything is from the same directory, which is called Gosu source, which is fine for us. So now we can output this file. It's not really going to be binary, but whatever, as f. And what we want to do is we want to, for each line in the source code, but we want to actually enumerate it. No. Enumerate returns another, like that's a way to get count which index are you at, basically. In JavaScript you don't have to do it if you use for each, in Python you have to use this, this construct, function, whatever. Now, I is actually one line off, I believe, so the actual line number is I plus 1. And if line number is in, or like in files of path, this is actually v, we already have it in here, we have in v, this is the set, right? In that case we want to echo it, but with a comment. This is C code, so let's add a comment. So what we want to do, yes, we did do split lines, okay. So we need to add another new line. So I'm going to add a comment like this. Okay, just cov, like cov for coverage. And this comment takes 9 characters. I'm going to make 1 space, and then I'm going to add to it whatever is in the whatever the line is, which is ln, and I'm going to obviously write it to the output file, which is f. If this line is not in the coverage, then what we want to do is we also want to write the spaces, but we do not want to write the coverage, so we know it's not there. And at the end, when it goes through all the lines, then yeah, that's it basically. Let's run it. And it doesn't like my, I always forget this. I forgot about this. I wanted to do this after strip. So if ln is equal to this, then that's the main reason I added strip actually. Then continue. We don't care about this line. Let's skip it. Okay. And it did something. So now, if we actually, let's do ls on conv output. You can see these files, right? The files, these are the only files which are covered, which means that any other files which are in the project, and there's quite a lot of them, have not been covered. And now we can look at the script parser thing to see which parts exactly were covered. So I'm going to open it here, and as you can see, it is misaligned, and like, yeah, like these lines weren't covered because this isn't really code, right? This are like information for the compiler. So this wasn't covered. Is there anything which was covered here? This part was covered. which is quite funny because this function is not set to be covered, but this is kind of expected in these cases but we are missing this information. But you know what? Before we get there, I'm actually going to make sure I'm not making... No, we have BB here, which is weird because... Okay, it should be fine, but I am going to regenerate our Sanko file because I see we have to... Oh, this is interesting. I see we have two Sanko files. Where's my... Yeah. One of them is opened. Okay. And I'm going to regenerate it. So... yeah, I'm going to run it again, and I'm going to rerun the script. I'm going to remove everything from that directory, and I'm going to rerun the script on this file. Perfect. Now let's open that file again. The script parser. Because I'm pretty sure I had the edges there instead of... Yeah, this behaves way better. Edges behave weird in some cases. So what we see here basically is that we did enter this function, right? This function is somewhat covered. This line was executed. It doesn't have the coverage information that it was covered, but if we are using the BB coverage information, which is basic block, then you only get information at the beginning of a basic block. So all the code before each if is basically like even these ifs are in the same basic block. Basically everything in the scope of this is the same basic block. But since there is no coverage information here, that means that this has never been executed. And that is really probable because CFG is not null. We are making sure it's not null in our here when we are actually running this function, right? We are making sure that it's open. So here we are making sure that conf isn't actually null, and because we open an actual config. So this is logical, but this was not executed. This was not executed either, which is fine because that's just error checking. This is again error checking, not executed because we didn't run out of memory. Because, well, it's okay not to expect this wasn't really didn't cause any problems. This line, of course, was executed because it's in the same scope, in the same basic block, right? Like this is a separate basic block, or rather, this is a separate basic block. This is a separate basic block. This and so on and so forth. Now, an important thing here is that basic block doesn't really have a really solid definition. Like every tool might define a basic block differently. For example, for some tools, some tools might emit a coverage information for this instruction as well, and it might emit one for this instruction, but it might not emit one for this because this was not reached, for example, right? So it really depends, and you have to know how to interpret it, but I interpreted this way that this was executed, this check was executed, this was not executed, check was executed because it's again in the same scope, not executed, executed and executed, not executed, executed, not executed, but these are again just checks, so we don't care. Again, a check, like just a normal check, not executed. Then this was executed. We are in some, we are in the same scope. How is it? Yeah, and obviously this was also, return was also executed. It's pretty weird that it decided to put this here, but it also boils down on how exactly on the assembly level this looks like. You know what we could do? We could actually open this Gosu, this file in IDA and take a look. So let's open it in IDA. That might make it a little bit more clear what exactly is a basic block, and that's also a way you might want to do it. You might have to have Gidra or IDA or Binary Ninja opened. So that's fine. Now let's look for... There will be a lot of ASAN stuff here, so do not be afraid of that. It's still thinking because it's a pretty large file. So okay, close was executed, this wasn't executed, this was executed, and this was also executed, and it also left the function. Now what we want to look at is the src parser open. Yeah, this doesn't look too good because there's a lot of async stuff which does branches, but we probably would have to compile Gosu cov without actually using. We can do that. Where's our here? I'm going for a second to comment these two things out. Okay, and I'm going to create like an X version. Okay, and now I'm going to revert the changes. I'm going to open that X thing in IDA. It's, by the way, 40 kilos instead of like 1.7 megabyte. Okay, and we go here again. Yeah, and looking here, I guess it's a little easier to see where the basic blocks are, like these things are basic blocks. But on the other hand, a tool, if some jumps are not made or are always made, might not generate a given block information. It gets some. I know I'm not making too much sense, but if you think about it, and I totally encourage you to do that, then it will be pretty obvious which line was executed and which wasn't. So, but again, let's go back to our code here. And yeah, the more fun stuff. So this wasn't executed, and this wasn't probably executed for some reason, at least for that one, because we are currently analyzing it only for one file. What we really need to do is to analyze this for like the whole corpus of files. But yeah, for now we can basically see that like some things were never executed. This was never executed as well because there are no parameters, so this was never executed, like we never got into this loop. And yeah, and so on. So what we could do now actually is we should run the fuzzer and save the corpus somewhere and then get that corpus and run it through our script. So let's do just that. And while the fuzzer is running and generated a corpus for us, I'm going to try to answer some questions. So we still have the fuzzer here. Wait, don't go. No, you're too fast for me. Lib fuzzer. How did you tell? Okay. Corpus directory, yeah, this and oh, we just passed the corpus directory. Okay, that's fine. So that would be corpus too. Okay, and it's running, and I can see that it actually fills that directory with different stuff. So let's leave this running and let's look if there are any questions. If you have any questions, ping Foxtrot Charlie because he will be able to pass me the question. And there's only one question from Przemek. Have you heard that some newer Asus motherboards do inject Asus software into freshly installed Windows 10 using some UEFI mechanism? Really? I didn't hear about it. If you have any links, then let me know. That sounds really wrong, depending on what they are doing. I mean, if it's injecting drivers, right, then that's fine. Probably like Windows might need some drivers for the motherboard really early during the boot, so that might not be wrong. Depending if it's using also some documented mechanism, it's actually Windows querying UEFI and grabbing some additional drivers from there, or is it actually doing some bootkit-like magic and hacking Windows kernel on the fly while booting? Then that might be a little more scary. If you have a link, Przemek, do let me know. Okay, no more questions. At least there are no more questions. Oh, there's one more question. Have you heard about devdocs.io? Devdocs.io. Huge documentation, like 90 languages. Okay, I did not hear about it. Let's see what do we have here. Wow, that's really cool. I didn't hear about it. SVG. Alright, that's nice. Thank you. I am going to save myself. Well, save this link in my personal bookmarks. Let's put it here. Nice. Okay, now we can stop the fuzzer. And let's see how many files do we have. So ls/li corpus 2. Yeah, 364 files. That's fine. And now what we want to do is we want to run the corpus grabbing thingy, so this thing, on all the files in that directory at the same time. But this isn't the best way to feed the file list, in all honesty. So a better way would be to here, no, not here, I'm sorry. Here in this main file, like grab a list of files, like, or take a directory or a mask of files as an argument and go through each of these files and run this function one time for each file. But yeah, it's not what's happening in our case, so we do have to do this. Okay, it ran, and as you can see, there are more basic blocks which have been noted down. So we can now run our show coverage again, but yeah, okay. And now we can take a look again what exactly was covered. Did I? No, I didn't. Okay. As you can see, it reloaded, so that's fine. And now we are actually entering this loop, which we were not entering before because we have a larger coverage. Yeah, and what you want to do now is you want to basically go almost line by line and figure if, hey, can I do anything to enter this loop, for example, because we are not entering this loop at all. And there is this funny comment here like, hey, sorry, no buffer overflow, and each time we saw this comment, there was a buffer overflow. So what should we do to, for example, enter this loop? And as we can see, we have to make sure that some, yeah, like a value has to exist in a temp environment buffer, whatever that is. This value has to exist, and if that value exists, then we do this. What kind of temp end is that? I don't know. We would have to probably learn a little more about the scripting language to be able to create a test case. But what you want to do then is you want to create that test case and put it in your corpus and like append it to your fuzzer which is running, or like stop the fuzzer, put the new test cases into your fuzzer, and then rerun the fuzzer with a larger corpus where you know there are samples which will reach this part. And if you have now this might sound a little counterintuitive because the whole idea with genetic fuzzing is that it will reach all these branches on its own, right? So why do you have to help it? Won't it reach it at its own at some point? And if you just can create a test case which will reach this basic block, then doesn't that mean you don't really have to run the fuzzer on it? You can just like run it once on this thing which reaches the basic block, and that's it. No. First, because as I said before, there is no guarantee that you will actually reach the like any and all basic blocks with a fuzzer, because there might be some conditions which are not probable to appear in mutation-based fuzzing. So that's one thing, and the other thing is that even if you reach this thing, that means you have reached the basic block. It doesn't mean that you have actually explored all the states, all the possible states in a given basic block. So if we look at this basic block, there are actually multiple states in it, depending on like various variables and various conditions. Like for example, if this I have no idea where I comes from, but this block of code has a different state for each value of I. If it starts with I equals to 0, then it will enter a different state than the value is of 1. If this points to like a short string, it's a different state than a long string, and so on. So there's, per each block of code like this, there's like literally thousands, if not millions, of possible states, and sometimes billions, or like even more. Depending on, like, the more variables you have, basically the larger the number of states are. And fuzzing is a technique which basically randomly selects a state and tests it against, like, will it crash? So even if you can reach here, you can just like and if you run it, you can just reach one state, and then you give it to a fuzzer which can randomly explore more states in the same block of code. So that's why you need fuzzers, because it will really fast, really quickly explore a lot of states. All of them? No, almost never. You almost never explore all of states, and I guess that doesn't really matter, because what you care mostly about are some like edge states which might lead to crashes and so on. And some fuzzers do have these like magic values, for example, which are supposed to tell the mutator to inject this magic value, which is like, for example, known to cause overflows because of +1 or something. And mutators commonly inject these magic values, and they are supposed to guide the fuzzer on some state which might be crashing. So yeah, that's why fuzzing will not find all the vulnerabilities as well, because it's just not feasible to explore all the states dynamically. There are too many states in an application. But still, randomly poking around and randomly selecting different states, what fuzzing is all about, yields really good results. So yeah, you might need to help the fuzzer get here, and in our case, I'm pretty sure we would have to write another, like 2 instructions to actually get here, which the fuzzer, it's not really likely, but the fuzzer will write these 2 instructions to allow us to get here. So that's why we would have to help the fuzzer reach it. Now, well, if we reached here, it's pretty obvious we also reached here. Then we reached here, that's fine. Do we reach here? If we reach here, then we have to reach here. That also makes sense. So again, it's not noted, but we can totally see that if we have reached this place, we do have to be able to reach this place and as well. Unless there is some return somewhere here, then that might not be true, but in such case, I'm pretty sure there would be more information here for us. Or maybe not. You have to look at the code as well. So yeah, there's a lot of other stuff here. Let's look at another file for a change. And let's make for that file to be yeah, for example, there's variable list thing which we see all around. Like which functions of this library are actually called. Like this create is called, destroy is called, but yeah, we don't ever enter this loop. This loop is not entered. So we might want to also think about how do we create such a script which actually fills stuff into a variable list that the destroy function actually has to clean up the linked list. It's a good question actually. Then clean is also being called, and the for loop is also being called, or actually like this is being called. I'm not sure about if this is being called. Maybe this is what this means actually, what it is called. You can always check, if you're uncertain, you can always check with a debugger. What we could do here is we could set a breakpoint on this line and like run the corpus through the debugger and see if it ever breaks on this line. If yes, that means that this corpus, this coverage annotation means it actually did go here. Another thing which you can do is you can in the source code actually like split the line like this and run it again like the whole stack. And if the coverage would like appear here, for example, then you would know that, hey, but like instead of here, you would know that it actually entered the loop because it executed this iteration part. So that's like a simple trick. Oh, by the way, if I'm pretty sure the code which I'm looking at is linked somewhere in the description of the video, but in case it isn't, it is on my GitHub. So if you go to github/gunveil, and you go to, I think, random stuff like repositories, and there's one called random stuff. Yeah, random stuff here. Is this Gosu source? Yeah. Again, this is like a super old web server which I've written 15 years ago, when I was still on my like first year of or second year of university, something like that. Yeah. And this is basically like when analyzing a target, you basically have to do this process over and over again. You create new harnesses, you create new samples, like you increase the coverage until the coverage is this decent, and you also look at mutators. So I'm not sure actually what mutators are being used by. Well, we can see here what mutators are being used by libfuzzer, and you might ask yourself the question, hey, maybe another mutator class, another mutator style would be better, and you have to code it into the fuzzer. You might also want to create a generator for the scripts to have greater coverage. Sorry. Yeah. I'm wondering now if I should go into something deeper. But I guess the important message here is, again, if you do fuzzing, do this. Understand what parts are reached by the fuzzer. And if you do, then your fuzzing will yield better results. Just make sure you have great coverage by repeating this process. I guess I'm going to get the source code of this like show conf onto my GitHub as well, into the directory of this episode, if you want to use it. And I guess we still have some time, so I'm just going to tell you what else you could try to increase such a fuzzer. Yeah, so the next step, which I guess foreshadowed on the last live stream, is you'd go for a generator, basically. So since our structure of our fuzzer well, maybe not fuzzer, the structure of our I can, I guess, show you. Yeah, here we go. Yeah, this is basically what the fuzzer is generating. This looks weird. It reaches all the various points in the fuzzer, right? But it looks pretty weird. And so what you want to do, probably, you want to write a generator which at random creates properly formatted scripts in this case, right? And by properly formatted scripts, I mean like there's almost no, like a snowball's chance in hell of the fuzzer, of a genetic fuzzer generating something like this. And as you saw in the source code, some parts required us to register a variable, for example, so to basically do this thing, right? And there is no chance in hell that a genetic fuzzer will generate something like this on its own. There are a couple of ways you can approach it. One way to approach it is some fuzzers do have a functionality to create a dictionary, as in they actually go through all the strings in the source code, for example, and then randomly inject the strings into the mutated samples. If your fuzzer doesn't have this, add this, because it's a pretty fancy feature. You can always just give the fuzzer a list of strings you want it to inject. That's also pretty useful as well. Because if we would give the fuzzer like this string, and this string, and this string, and like maybe like including the quote here, and these strings, it might be able to gain better coverage, right? And this is, of course, like an example super related, super specific to the application. So in case we have a different application, like for example an image parser, you might want to think how to create a generator for an image. And for images, usually you do not write generators. Generators like this are super useful for parsers of any kind of text formats, mostly text formats, or for like, for example, serialization libraries, even binary ones, like think like Python Marshall, for example. You might want to actually create a generator for that. So how to quickly do a generator? I guess we have like, let's use 15 minutes and try to write a generator for this thing. So I'm going to call it gen py, and an important thing here, a generator usually does everything by the book, which means it creates proper code. And yeah, and then the output of a generator might be passed into a mutator. It doesn't have to, but it might be passed into a mutator, and the mutator would then like scramble it a little and, you know, to explore additional states. Even if these are like error states, you still might want to explore them. Sometimes in error handling there are mistakes as well. Okay, so what do we do? Well, we basically need to create a couple of lists. And one list would be to create these like commands. Let's call them commands. I don't know how I actually originally referred to them. Let's call them commands. So if would be a command. Actually, instead of doing it here, I'm pretty sure if we go to here, we have all the commands here. So it's actually add functions. This is how I call them. I call them add functions. So let's call it add function. So I'm going to copy paste it here. Here we go. And now I'm going to somehow, I need to like put this into multiple lines. So what I want to find is I want to find this, and I want to replace it with this, but I want a new line before that. No, before that I said. So I want, Okay, that works well. And now let's do this. Okay, perfect. So we have a list of functions. Now what we could also use would be the name of all the let's go. Yeah, all the attributes. So like right, then, and so on. To do that, let's use some script. It's not about, you know, rewriting, like writing it yourself. It's about actually being smart about it. So I'm going to attempt to be smart about it. I'm going to copy paste this into our directory to call it asdev Gosu. Okay. And let me open the console. Now let's do let's do something like this. Let's open this file like asdf Gosu, and let's read all the things which are there. And now let's split it with a space. Okay, and we have this. And now what we want to do is we basically want to display let's do like for some filtering. Let's create a set, okay? And let's go for I'm still thinking how to do it. Let's do it like this first. For x in k, if this is inside this in x. But then what we want to do is we want to split by this, and we want to get only the first element. And then we want to do a set on this. Perfect. So now we have the arguments. That wasn't the greatest idea. Again, this only in selected part. Okay, yeah, that's better. Yeah, so we have the arguments now. Okay. What do we need more? There is this like this variable, but these variables are actually more related to... Yeah, these are some strings. And I do not know if I actually care too much about what the actual strings are. And there's some HTML here. We do not care about HTML. We only care about this. So let's also have get some strings. Actually, let's create a function which gets a random string. So def string, and let's create a random string. How do we create a random string? It's a good question. And let's assume this n will be... Actually, you know what? It doesn't have to be a string, it just can be a character. So, and it's a good idea for it to be a character. Return random choice of string. How is it lower? I think it's lower or lowercase. Yeah, it's lowercase. Okay. And now we can create a function which actually creates, like, generates something like this. So generate expression. And we need to, this is going to be our output. And we first need to append, we do not, oh, we have that, okay. And we need to append to our output this, then we need to append random choice a function, an add function. So random choice and some add function. Then we need to append a space. Or do we append a space? Let's assume we append a space. Or no. And now for I in, let's create some like number. Or args, maybe. Let's go with args. We're going to go for a random number of arguments. So, and now for args, we want to random round int from 0 to 10. Let's go for 10. And in x range args, what we want to do is we want to append the space now, then we want to append the name of the argument, so arguments random choice of argument. And then we want to append this character and also this character, and at the end we will want to append a closing character. Closing quote, right? We're doing again everything by the book. And now, depending on, as you can see, there are three options here. It's either something like a variable with the percentages. It can be empty, I guess. It can be an expression. And if it's an expression, there are actually no... This is quite funny because there are no... Oh no, sometimes there are... It's escaped. So we can escape it, which is good. How did you do escapes in Python? Encode C-string? String escape? String escape. Yeah, exactly. Encode string escape. This will be useful. So actually what we want to do is we want to have a choice, right? A choice of what to actually insert here. And there will be a couple of options. There will be 4 options, right? So another option would be like the percentage char. So this returns actually percentage plus random character plus percentage. And I'm actually reusing the functions on purpose. Then another idea is going to be that it's supposed to be empty. So just return an empty string. And the last idea is to go recursive. And while going recursive, yeah, this is actually going to be a little funny, but we need to do it. Level equals 0, R&D expression. Okay, so we want to call it recursive expression, and this is the level. And what we want to do is we want to check if the level is equal to some boundary value. Let's say 3. 3 is already pretty it's a large number. Let's go for 2 maybe. That means there will be at least 2. Let's go for 3. Okay. Then let's return an empty string. Otherwise, what we want to do is we want to call gen expression, and it will return something. And what we want to return actually is this what generated expression, but encoded with the string escape. That's right, yeah, string escape. Because it needs to be escaped. Cool, but this is going to be level +1. We do need a recursive limit, otherwise it will just go into an recursive loop. Well, recursion, like almost infinite recursion until it crashes. And here what we want to do is we want to have a list of the functions which we might want to call. So random choice. Now choice will select a function for us. So please select one of the functions. The functions can be random character, random percentage character, random empty, or random expression recursive. And we call this with the level as the argument. And this actually returns a string, let's call it k. So out, append, and we append the k here. Okay, and at the end of the day, what we need to append is the closing bracket, right? Yeah, the closing triangle bracket, and we need to return this as a string. Perfect. And now let's do print gen expression and see what happens. Okay. This doesn't matter. Let's go. Since it doesn't matter, let's go. Whatever. Okay, yeah, and as you can see, it generated an expression. If we call it again, it generated another expression and another, and this generated. Why is it not escaped? Not escaped. What are you doing? It was supposed to be escaped. Doesn't. Oh, it probably. Yeah, it doesn't escape my quotes. Why doesn't escape quotes? Python codex. String escape. What about like quote? I am unhappy, but that doesn't matter because instead of this, what we can do is we can do a set of escapes actually. That replaces, so it's replaces. Okay, so k is equal to k replace all the quotes with this and a quote. Yeah. With an escape and a quote, then k is equal to, and also replace. No, before, but as the first step, actually also replace all the backslashes with an escaped backslash. Yeah, this is fine. And now return k. This is better. Oh, reverse it says that import string and string. Oh, okay. I reverse it actually showed me a proper way to create a random string in case it would be needed. I'm going to put it here because it is a nice way to do it. A pretty short one at that. Okay, now, yep, this looks better. There is quite a lot of... No, this is fine. Okay, what? Why? Wait, what? Oh, okay. YouTube somewhere always adds this character. Oh my, Oh, it's coding, not KrzaQ. No, whatever. Okay. Yeah, in case you didn't know, you have to add this at the like somewhere in the Python source code to make sure that you can use Unicode, like UTF-8 in the source code. Okay, so now what you want to do is you probably want multiple lines. So and we want, how many lines do we want? We want for I, for whatever, it doesn't matter, in random rand int from 1 line to, let's say, 100 lines. Yeah, 100 lines, because why not? It's actually, it gets quite complicated quite fast, so maybe no. And we want to print it and run it, and it says that it's an xrange. Okay. Okay. So now it generates stuff. Sorry. Okay. Now it generates stuff, so we want to actually create a corpus out of it, and to do that, we can just run it multiple times, right? But instead of running it like this, I'm going to create, let's do it like this. In Monody, in xrange. How many files do you want? 1000? Let's go for 1000 and see what happens. And then we do with open corpus 2, and then some file name, so it's just going to be called like this. Gosu let's go with this. Write binary as f, and we want to write this to the f file. We want to run generated expression. Okay, that's fine. Again, okay. And we can probably see these files in corpus 2. Yep, it's there. So, well, is it? Wait, I don't know if it's there. Yeah, it's there. So we can do now is we can actually restart the fuzzing. So the fuzzer runs for a while, and then see how if the corpus coverage improved. Actually, before I do that, what I'm going to do is I'm going to archive my coverage directory, so we can compare it in a second. And now I'm going to run again out corpus 2. Yeah, that's fine. And we are not showing the options, so some options 0. Okay. Yeah. Okay, it should go actually for a while, but I'm not going to allow it to go for a while. I'm going to take a look how many files were actually added or removed. And now I'm going to run our how was it called? Gosu. No, that was good. Gosu Kov. Wait, yeah. I didn't notice I actually have it. So yeah, and I'm going to run it like this. So you might have spotted that we don't really support this, and it's actually quite funny because on Linux this is expanded into multiple arguments by bash. On Windows that's not the case. On Windows you actually have to have a proper piece of code before main to be able to support asterisk out of the box. And I think Ming actually adds this piece of code. So yeah, it's weird. Okay, let's do it. Okay, yeah, the coverage hasn't increased by much, but it did increase indeed. So I think it did increase. And now I'm going to regenerate it. So show cov and this. Okay, and now what we can do is we can diff these two things, and to do difference on them. I'm going to use total commander for that, and there's a command synchronize directories, that's it. And I wanted to compare by content, ignore date, without subdirectories, and I want to show only things which do not match. And it shows only one place where it doesn't match, so this varlist file. And we can do compare, yeah. Okay, and here is what changed. White spaces, I do not care about white spaces, ignore repeated spaces. Did something actually change? There is no new coverage, it's lying to me. What did it do in that case that it actually increased the size of the file? Let's do a div. Sometimes div is like the best tool. Not corpus. To list. Okay. I don't know. It changed something with the spaces. I don't get it. Whatever. It seems that the coverage wasn't really improved by our changes. Now, I actually don't even know why. And the reason is that we generated proper code, right? But our fuzzer currently is not running enough. It's just running the parser, but it's not loading any it's not loading any plugins, I believe. We can actually check it. Yeah, it's loading this Gosu fuzz.conf, and this file has where is it? Oh, here it is. No, this is not the file. Where is this file? This config. It says the file. I do not have this config. That's weird. I'm reading a config which is not even here. Maybe I'm getting a null there. Anyway. Oh no, I might have it in a different directory. That's probably not it. Anyway, the reason is that here, when we actually played with plugins, we didn't list any plugins. And since we didn't even list the basic plugins, then none of these functions are actually run. And it would be great to be able to run these functions, but we will not be able to do it today because this code was written for Windows, and the plugins are using the Windows API to load the functions. So without some serious porting, serious, it would take half an hour basically to run the plugins on Linux. But yeah, we will not be able to run these functions, and that's basically, since we cannot run the functions which might do something interesting, we are not really getting any coverage. What we can, on the other hand, do is we can test the files which we generated on the real running Gosu thing, and to do that I need to copy them someplace. Just let me... Okay. Now where did I have the server running? Okay, so let's try. Oh, it's still copying. Okay, it's in fuzz directory. Requested site not found. That's fine. 000 Gosu. Okay, so I don't think it crashed because no debugger appeared, but it is displaying some funny stuff. I wonder if it will like disclose part of my. I'm kind of afraid of actually running it. Yeah, it does something. It totally does something, but it doesn't seem to do anything super interesting. Yeah, but it does something, so it might be worth running. What I would normally do now, if this would be a security review, right? I would actually port the plugins or try to make an end-to-end test on all of these. Or actually, I would request all these files using curl or something, which I guess we can do. So let's do. Let's go here. Can we do a curl? Yeah, we can do curl. Can we do a curl on this? We can do curl on this. Perfect. Now what I want to do is, let's just like can I do this? Yeah, I can do this. Okay. Can I do this? No, I cannot do this. Okay. So import os for in x range 1000. What I want to do is I want to do os system, and then I'm going to copy this. Yeah, this isn't a great way to do it, but cool. And run it, and I'm going to print I. And wait, here. Okay, perfect. Now, hyphen go. Yeah, and it's going. It's not so slow, but it's going. And I would leave it running for a night, for example. I would actually. Oh, did it actually go into some infinite loop? It seems like it's went to some infinite loop. So we might already have another bug. Oh well. Let's kill it and let's restart it. No, the server crashed. The server actually crashed. Let me check if the process exists. So I think we found another bug with the generator. The service is running, but it's not responding. Okay, that's pretty weird. Let's try to run it again, but this time I'm actually going to use debugger. Okay, let's run it again. It should be reproducible in each case. Yeah, so using such, okay, and it's stuck again. Wow, it's stuck enough that I cannot even. That's weird. I cannot even break it in a debugger. Oh well. I'm actually going to leave the analysis of what happened here to you, since I guess we're running out of time. Now the next step, what you might want to do after like writing generators and doing the end-to-end test, because you want to fuzz everything, the whole server, not only like the part of it, right? You might want to. It's a good question. What would be the next step? I would actually leave the fuzzers running like that have like great coverage, and at the same time I would probably just go line by line through the server and try to look at any more bugs I can find. So that's about it for today, actually. Oh, -s I was looking for the flag and curl, which is silent probably instead of quiet. Whatever. Thank you, Terril, anyway, for pointing it out. So that's it for this topic, actually. So for the code review topic, we did do black box, we did do white box, we did do fuzzing, we did do some actual iterations on fuzzing, a generator. So I'm quite happy with the content. I hope it did teach you folks something. Now, next week, I'm going to do reverse engineering a VM-based protection. Like a VM, well, basically an application where part of it is a VM implementation, and the logic, like the super secret logic of the application, is actually in some bytecode for a virtual machine. So yeah, it's a pretty like basic type of protections, but they are really good. I guess we can take a look how it works. So that will be next week. And if you speak Polish tomorrow, I think we are going to play more with the Linux terminal, since I'm writing a Linux terminal on the Polish live streams for some reason. Yeah. So thank you very much. I am going to answer the questions, since there are 4 questions. What better language to offer beginners, Python, JavaScript, or something else? Both are fine. It's like this. Python is a little more serious language, and while JavaScript, you can optically see the results pretty quickly. And that's at the beginning, at least for me, it was really important to see some part of graphics moving or some graphics appearing on the screen. That really boosted motivation when I was learning. So JavaScript here is, you can use out-of-the-box JavaScript with a browser without even installing any development environment, right? And you can play with like graphic effects and so on. So that JavaScript is amazing in that sense. But on the other hand, in JavaScript, you write applications in a different way because you cannot have any blocking functions. At least that was usually the case, right? You have this model where you are operating basically on like fibers and asynchronic functions basically. And that's different than almost anything else. As in, you can write code in this style in Python, you can write code in this style in C++ and so on, but that's not the default way to do it. So if you learn programming with JavaScript, you will have to then learn a different way of doing things using C++ or Python. But that's fine. I mean, that's still fine. JavaScript is still needed, so that doesn't put you in a bad spot either. Python, on the other hand, is also more, it teaches you to indent your code properly, which is a good habit to have for any language. And it's pretty easy and it's really powerful. So that's also a good choice. Apart from that, I don't know, these are usually the languages I would recommend. I also sometimes mention C#, but I would actually go for either Python or JavaScript. What about fuzzers that knows to change Z flags to cover all the program? I'm not sure what you mean by change Z flags, in all honesty. Well, there are fuzzers based on stuff like SMT and, like, for example, Microsoft Sage is one of them, and there are a couple of more which try to solve the equation of how the input is supposed to look like to reach a given basic block. And it's slow, it's super slow, and there are some hard problems there. But if you take that and you basically like add it to a genetic fuzzer, that setup is like super powerful. So yeah, totally try it. Oh, Item is about like a fuzzer which actually changes jumps to cover all the program and the flags. It's an interesting idea, but do note that even if you find a crash, that doesn't mean that is a legit bug, because you do not know if you can actually, using the input, you can actually modify the same flag. So I would be afraid that it would put a lot of noise into the process. You would get a lot of crashes which would not be reproducible on a real system. On the other hand, that might not be a bad idea. There might be ways to get rid of it. I need to think about it. That's a cool idea, but I'm not sure if it's usable due to the noise. Because again, it's not about the coverage, right? It's about what you can cover with input. And yeah, if you can cover something but with changing the code or like the execution flow, then that's not really, you don't really control it using just input. Would it be a good idea to add existing known good code to a corpus? Yeah, sure. Totally. Because I guess that's what the generator did, because the generator did generate syntactically correct code which doesn't make sense from like a logical perspective, right? But it was correct code, at least on syntactic level. And that makes sense because the corpus, the fuzzer, will grab this and mutate it. And since parts of this code will allow to reach certain branches, then at least that's the theory. It didn't work today, but it would work if our setup would be a little better. That's a good thing. That's already a win. So it's fine to add good proper cases to the corpus, and that's usually the way you start anyway. And Matej says that sorry, how do you read it? Matej, Matesh, Matej, Matech? I don't know. I apologize. I'm really bad with names. Div-w probably means like compare directories, I guess. That's my, or like, I don't know what it does, but it might help us in the past. I'm going to take a look after a stream what does it do. Anyway, that's it for today. Thank you for being here. Thank you to Foxtrot Charlie for being my moderator today. His nickname is right there. And see you in 1 week. So that's it. Yeah. I'm going to leave you with some music. Have a great evening or a great day.